Okay, so like I said, 4.3 is conics. So the definition or the different types of conics are circles, ellipses, parabolas, and hyperbolas. We'll eventually get through all 4 of these. We're going to start with a parabola. They are all based on this. It's called a double napped cone. So if you could think of like an hourglass shape, okay, if you were to cut it horizontally with a plane, what's left off would be that round, perfectly shaped circle. If it is, all right, so we talked about the circle, right? Then if you were to take and slide a plane through a horizontal plane, like an angle, it causes an ellipse or like an oval. If you were just to chop off the little edge of it, then that creates the parabola. And if you went through a vertical plane, you'd end up with a hyperbola. So those are the 4 conics we'll eventually talk about. Again, today we're going to focus on the parabola. So we did parabolas, right, already. We talked about them in quadratic form. We talked about how to complete the square, how to do all those things using ax squared plus bx plus c, or the standard form where we shifted left and right. This is a little bit different. We're going to start to talk about things like a directrix, a focus, okay, and then we're going to learn how to graph them based on that information. So the parabola by definition is all the points in a plane that are equidistant from a fixed line, and that line we call a directrix. So if you remember back to quadratics in the beginning or last semester, we had an axis of symmetry, which is still there. That one runs through the vertex and it crosses through the parabola. The directrix is always behind or right or left of the parabola, and the parabola points away from the directrix. So this is a line in which if I did the distance from these two, they would always be the same. You don't really have to find those distances. You just have to know that you're going to plot a directrix. A directrix could be vertical or horizontal because these parabolas are going to turn. They can either open up, they can open down, they can open right, they can open left. But the parabola never crosses through the directrix, okay? It cannot. The midpoint between the focus and the directrix is the vertex, which means that the same distance from here and here and here and here. So those values are the same. If it's 2 units away, it's 2 units away on both sides. And the line passing through the focus and the vertex is the axis of the parabola, which you already know, okay? So the focus is the point inside the scoop, and the directrix is the outside. This, again, can turn right, left, up, down. Focus will always be inside. Directrix will always be outside. The standard form of a parabola is now a different equation. So the standard form of the parabola with a vertex of 0, 0, so if my HK is 0, 0, then we either use x squared equals 4py, or we use y squared equals 4px. Notice this squared term is on the side by itself. And then this says the focus lies on the axis p units away from the vertex. So whatever p is how far away I make the directrix, and then how far away I make the focus. So you're going to get an equation. Again, this is if it's got a vertex at 0, 0 that says something like x squared equals 16y. This number here is my 4p. I would solve for p. I would plot my point at 0, 0, and I would count either up, down, right, or left, depending on the variable that's squared, which I'll teach in a second. Whatever that unit is, which would be 4 this time. Yep. If it's an x squared, these are the ones we know. These point up, and these point down. If it's a positive 4p, it points up, and if it's a negative 4p, it points down. So if the x is squared, it's the ones you already were used to. Those point up and those point down. So if there's no value inside parentheses, which is going to affect my HK, which are these, I would plot a point at 0, 0. So for this one, I would plot a point at 0, 0. I'd count up 4, and that's going to be my focus. And I'd count down 4, and that's going to be my directrix. And then I'd draw the parabola, scooping around the focus. If it was x squared equals negative 16y, what changes about the parabola? Good. So now I would draw the same vertex, so it would still be 0, 0 for now. This is still 4p, so I could say negative 16 equals 4p, but the only effect of the negative is which direction it faces. P itself is still 4. I would count this time down 4, that's the focus, up, that's the directrix, and then I would point my parabola down around the focus. So again, in this scenario, both the x's are squared. What changes if the y is squared is this now faces right or left. So a y squared with a positive 4p points to the right, and a negative 4p points to the left. So if I had y squared equals positive 16y, I'm sorry, that should be 16x. This tells me I have a vertex at 0, 0 still. This time, again, 4p equals 16, so p equals 4. I would count right 4 places, and that's my focus. I would count left 4 places, and that's my directrix. Parabola folds around the focus. And if it was y squared equals negative 16x, the only thing that changes is where the direction of my parabola goes. So I'd still have a vertex at 0. I'd count to the left 4. That's my focus. I count to the left 4. That's the directrix. And I'd point my parabola around the focus. So x squared positive up, x squared negative down, y squared positive right, y squared negative left. Okay, that's like the basic foundation. And then again, this is all for if my vertex is at 0, 0. That's where we're going to start. Then we're going to start to shift it. Questions so far? Actually, hang on. Okay, see if. All right, so looking at the first one, what do we know about the parabola? It points up. Good. X squared and a positive 4p, right? So then I want to take that 8, set that equal to 4p, which makes p what? 2. So I draw my vertex at 0, 0. I go up 2, and that's going to be the focus. I go down 2, and that's going to be the directrix. So the focus is a coordinate point. The focus is going to have x, y values. This would be 0, 2. The directrix is a line. This is a horizontal line, so this is a y equals negative 2. So focus, coordinate point, x, y coordinates. Directrix is always going to be a line. It could be vertical or it could be horizontal. This time, it's the actual directrix is horizontal, so it's a y equals. And then I would just draw my parabola around the curve. So you don't need exact points for the rest of those. You're kind of just approximating it, but you are finding exact points for the vertex, the directrix, and the focus. Okay. How about 2? What can you tell me about 2? Points to the left. Good. So this 4p is 28, which makes p 7. So again, vertex at 0. This time I go to the left 7 to get the focus. And I go to the right 7 to get the directrix. So focus, negative 7, 0. And directrix, x equals 7. Yep.
Is it okay if you put the coordinate for the directrix?
No, you want a line. So you want it to be an equation. So the coordinate is for the focus, but for the directrix, you want it to be x equals or y equals, depending on what kind of line it is. Questions so far? All right, so tell me what you notice about these two. Good. There's now the number on the front of the squared term. The squared term has to be by itself. There can be nothing on the front of it. So how would I move that 4x squared? How do I move the 4? divide it. So I'm going to divide both sides by 4, and I get x squared equals, this is y over 4, which is the same thing as 1/4 y. Now what do we know about this parabola? It opens upward, okay? 1/4 equals 4p. So I would divide both sides by 4, multiply by a 4th, which means p is 1/16. My vertex is still at 0, 0. We said it points up. So I'm going to go up 1/16. That's the focus. 0, 1/16. And I'm going to go down 1/16. And that's the directrix, which is a y equals negative 1/16. So they will not always be whole numbers. Yeah.
Can you do the top part again?
Yeah, so as soon as you notice that there's something on the front of the s squared term, you got to get rid of it. If that was x squared over something, I'd multiply by it. But because it's multiplying, I'm going to divide both sides by 4. So it cancels from here, and I would get x squared equals y over 4. But you don't want to leave it like that. You want to pull the 1/4 out. So this is really a 1, and I just rewrite it as 1/4 y. We're going to do it again, because now it's on the y squared, right? So I would take and divide both sides by 8. This cancels, and I get y squared equals x over 8, which is the same thing as 1/8 x. All right, 4p equals 1/8. Divide both sides by 4. And I get p is 1/32. So vertex at 0, 0, right 1/32 to get the focus. Left 1/32 to get the directrix. So this is an x equals negative 1/32, and this is 1/32, 0. Questions on that one? Okay, so now what happens if we shift our vertex off center? So our HK is no longer 0, 0, okay? You'll know this by the parentheses. There will be parentheses with the x, or there will be parentheses with the y. You could have it on one, not the other. You could have it on both, okay? But whatever's with the x is your h, and whatever's with the y is your k. We switch the signs, though. So if I have x minus h, then I change the sign on whatever follows x. So it's just like our horizontal shifts. If you remember the horizontal shifts, we always switch the sign. It's the same kind of concept, okay? When we take that variable or that number out, we change its sign. Same for the k. So this would look like x minus 3 squared equals 4p, so it could be like 16, y plus 2, something like that. So what this is it has a h that would be positive 3, and a k that would be negative 2. So we change the signs of whatever follows the variable. And then that's your vertex. And then you still find p the same way. You still set 4p equal to the number that's there. So in this case, 4p would equal 16. P would equal 4. And instead of just counting off of 0, 0, we count off of this vertex. So that vertex, which would be 3, negative 2, would be my starting point. Because it's an x squared and a positive 4p, this points up. So from 3, negative 2, I would say I would count up 4, 1, 2, 3, 4, and that's my focus. And I would count down 4, and that's the directrix. There's ways to do it without drawing the picture. I know for me, I need to see it. Like, so I would recommend until you get the hang of it, at least you do that. But once you understand what you're doing, once I know where this is and that it's vertical, I know I'm changing the y because I'm going up or I'm going down. So I could take that -2 and I could subtract 4 from it, and I would get this coordinate point here, which we went down 2, and then we went down another 4. So this is -6, and I get y equals -6. And then I could take that -2 and add 4 to it to get the focus. 1, 2, 3, 4. Or I use my coordinate grid, and that's 3 +2. So I would say more often, I would recommend doing the actual drawing of it. It's going to help you visualize it, okay? But you don't have to have a drawing to figure that out. You just got to know which direction it faces, and then that's the one you add the p onto. If it's x squared, I add p and subtract p from the y coordinate. If it's y squared, I add it and subtract it from the x coordinate. But all the other rules still apply. The x can't have anything here, okay? The squared term can't have anything on the front. You'd have to move it to the other side. It obviously can have something in the parentheses because that causes the shift on the vertex. If it's a positive x squared, it opens up. Negative x, or x squared with a positive 4p, it opens up. X squared with a negative 4p, it opens down. Y squared with a positive 4p opens to the right. Y squared with a negative, it points it to the left. Everything else is the same. The difference is, where do you start? All right, so the first thing you want to make sure is that there's nothing on the front of the x. In this case, because the x is squared. If there was something there, I have to move it before I determine what direction this goes. That's already done, right? There's nothing in front of that x squared term, which tells me which direction does this face? Up. What's the vertex? Good. +3, -2. And my 4p is 4, which means p is 1. Yep.
So the p is always the number in front of the y?
The 4p. Yep. Well, it won't always be in front of the y, but it's in front of the one that's not squared. Yeah. So again, I would probably recommend that you get like a coordinate grid and you start using it because it's going to make your life a little bit easier and more accurate. You can do this without it. You just got to be careful. Now I'm starting at 3, -2. So 3, -2. And I know my parabola opens upward, so I'm going to go up 1 point, and that's the focus. And I'm going to go down 1 point, draw a line, and that's the directrix. Parabola folds around the focus. The coordinate point on the focus is 3, -1. And the equation on the directrix, this is -3, is y equals -3. So you can either get that from the picture you just drew, or you can say add and subtract p from the y coordinate of your vertex. So for the focus, I would do -2 plus 1, and I would get 3, -1. And for the directrix, I would do -2 minus 1, and I would get y equals -3. I think it's easier to do it from the picture, but you can certainly do it without. All right, tell me what you know about this one. What would you have to do before you decide the direction? You got to move that -4. So I divide both sides by -4. And I get x plus 3 squared equals -1/4 y minus 2.
What do you know when the parabola is facing down? It would be -x plus 3, right?
No, so that you want to wait until you move it. The reason is there could have been something here. So if there was something negative here and then you move a negative, it changes it. So you wait until it's just squared. There's nothing on the front. Move whatever you need to do like we just did. And then you look at this and say, okay, it's x squared and it's a -4p. So I know this opens down. What's my vertex? Good. -3, +2. 4p is, and you can make it -1/3, or you can just do 1/4, sorry. Or you could just do 1/4, it doesn't matter. P is technically -1, but all that does is tell you which direction to face it. So I would get divided by 4, multiply by 4th, and it's 1/16. But I know this opens downward because of the negative. So the P is the distance between it. That's why the sign doesn't matter, right? Distance, we don't use a sign. So now I'm going to plot here, let me actually bring in. I'm going to plot my vertex, -3, 2. And then P is up and down 1/16. So I'm going to go up 1/16. This is 2 and 1/16. I added 1/16 onto the 2. So this is -3. And then I would subtract 1/16 or move down 1/16. So that's 2 minus 1/16, which is 1 and 15/16. You can give it a least common denominator. You could change it, whatever you need to do to get there, okay? I could have made that 32/16 minus 1/16, which is 31/16, which is 1 and 15/16. Or you can make this 1 and 16/16 and then subtract. I've seen people do it both ways. They're both right, okay? You could like borrow the 1 and give it the 16/16. Either way, you want to get to the point that it is 1 15/16. So that's what this is. And we said that a parabola points down, right, because of the negative. So the one up from it is actually the directrix. So our directrix is y equals either 2 and 1/16 or y equals 33/16. Either answer is fine. And our focus is a coordinate point, -3 and 1 and 15/16, or -3 and 31/16. Questions on that one? Okay, this point's right, and our vertex is 3, 2. Again, point's right. The 4p is 24. P is 6. So from here, I'm going to go to the right, 6. That's 9, 2. And I'm going to go to left, 6. So focus, 9, 2, and directrix, x equals -3. So we did it with the other one, but if I was doing this without the graph, because it points to the right and to the left, or it points to the right, I know I'm adding and subtracting from the x coordinate. So I'd be adding and subtracting 6 from 3. Adding 6 puts you at 9, 2, that's the focus. Subtracting 6 puts you at -3, and that's the directrix. Okay, so you could do it both ways. I would recommend definitely doing the pictures until you get the hang of it, but you can also do it without drawing that graph. Now we're good, yes? Okay. So again, on homework, every question you need a hand-drawn parabola. And then you can pick it from the multiple choice. So yes, you could probably, if it was multiple choice, use process of elimination, maybe even when you just get the vertex or something like that to start to do it. But what you need to do is show the work to get to that point. So you need to show, there's only 6 of them, but you need a hand-drawn graph, and then the directrix, the vertex, and then you'll type it in, okay? As soon as she comes back. Yeah. Because it's the whatever follows X and then whatever follows Y. Yeah.